Hello students, in our previous class we have discussed about kinematic equations. We have derived all the equations. Today we will study different types of graphs for the motion of a body. First we will study distance versus time graph and displacement versus time graph. There are several situations we will study. Number one, the body is stationary. That means a body is not changing its position with respect to time. Here, distance and displacement are plotted along y-axis and time is taken along x-axis. Now here, see, time goes on increasing but position of the object remains constant, remains fixed. So, we will get a straight line parallel to time axis. Here, time is increasing but distance is fixed. Here displacement is fixed. That means the body is not changing its position with respect to time. So the body is stationary. Number two, a body moves with constant speed or constant velocity. That means in every interval of time, the body is covering equal distance or equal displacement. So we are getting a straight line passing through origin. Here the slope of this curve, say it is theta, this slope will give us the speed or velocity of the object. Okay. Here it is written, speed of the body is equal to slope of OA line and velocity of the object is equal to slope of OA line. Okay. And at any instant, this slope will be same. See, if we take here, then this slope will be same. So the body is moving with constant speed or constant velocity. Now number three, two bodies move with different speeds or different velocities. You can see two graphs are here. In distance time graph, body A is moving with one speed and body B is moving with some another speed. Now from this diagram, we have to tell which one is moving faster. From this graph, we can see for body A, if the slope is theta 1 and for body B, if the slope is theta 2, we can see that theta 2 is greater than theta 1. That means slope of OB is greater than slope of OA, and we know slope of the line represents the speed of the body, and in displacement time graph it is velocity of the body. So here speed of the body is greater than speed of the body A, speed of the body B is greater than speed of the body A. Here it is velocity of body B is greater than velocity of body A. Okay, so more the slope, more will be its velocity. More the slope of distance versus time graph or displacement versus time graph, more the speed of the body or more the velocity of the body. Okay, now come to fourth situation. A body is moving with increasing speed or increasing velocity. Here, body is moving with increasing speed or increasing velocity. That means the body is moving with uniform acceleration, and we know the formula S is equal to ut plus half a t squared. This is the equation of a parabola. If initial velocity is 0 or initial speed is 0, then S is equal to half a t squared. So this represents a parabola. So this will be, the curve will be parabola. Okay, this is the displacement time graph. This is the displacement versus time graph. Here, instantaneous velocity of the body we can find as we have to draw a tangent. I'm sorry. at any point. Suppose at this interval we want to find out the instantaneous velocity of the body. Then we have to draw a tangent at that point. This angle will be theta. This slope will give us the instantaneous velocity at this point. Okay, so instantaneous velocity of the body is equal to slope of a tangent at any point on OA. Okay, similarly, instantaneous speed of the body. Similarly, we have to suppose at this point we want to find out instantaneous speed of the body at this interval. Then we have to draw a tangent at this point, and this is the slope theta, and slope of tangent at this point on OA line will give us instantaneous speed. Okay. Now, when the body is moving with decreasing speed or decreasing velocity, here just S is equal to ut minus half at square. Okay, because the speed is decreasing. That's why the velocity is decreasing. Therefore, we will get the equation of a parabola. So the graph will be like this. Okay. Now come to velocity time graph. First case, a body is moving with constant velocity. Velocity time graph, velocity is represented along y-axis, time is represented along x-axis. Now first situation is the body is moving with constant velocity. That means there is no acceleration. There is no change in velocity with respect to time. So as time goes on increasing, velocity remains fixed. So we get a straight line parallel to the time axis. Okay, your acceleration is 0 and displacement of the body we can find the area under this curve. Because see, V is equal to, okay, S is equal to Vt, because here body is moving with constant velocity, there is no acceleration, acceleration is 0, so there will be no half at squared term. Okay, so S is equal to Vt. Now here in this rectangle, if we complete this rectangle just like this, then one side is time, another side is velocity. If we multiply these two, then we get area of this triangle. Okay, so which represents the displacement of the body. Okay, so displacement of a body is equal to area under the Vt graph. Okay, the next situation, the body is moving with constant acceleration. That means velocity is increasing with time at constant rate. And here the nature of the graph will be a straight line passing through origin, because as time goes on increasing, velocity also increases at the same rate. So if theta be the slope of the line OA, then this slope, this theta, tan theta will represent, suppose this is the triangle. Okay, and this time is t and this is the velocity v. Then what will be tan theta? Tan theta will be, actually this is v, say. Okay, so tan theta will be v minus 0 by t. If we put a name, suppose it is AD, so it will be AD by OD. AD by OD, perpendicular by base. AD is nothing but v minus 0 divided by t. What is it? V by t, change in velocity by time. This is nothing but acceleration. Okay. So acceleration is equal to slope of AOA curve. Okay. Now two bodies moving with different constant acceleration. From this graph, we can see body A and body B both are moving with constant acceleration, but the acceleration for A is different from that of B. Now, suppose slope of OA curve is theta 1 and OB is theta 2. We can see from the graph theta 2 is greater than theta 1, and we know slope of VT curve gives the acceleration of the body. So here acceleration of body B is greater than acceleration of body A. Okay. Now a body is moving with negative acceleration, or a body is retarded and finally comes to rest. The body is moving with a negative acceleration. So here the curve will be like this. See, as time increases, velocity decreases gradually and finally it comes to 0. Okay. So this is the nature of the curve. Therefore, retardation is equal to slope of curve AB. Okay. Now the body is moving with increasing acceleration. Here the body is moving with increasing acceleration. It is not moving with constant acceleration. If it moves with constant acceleration, then we get a straight line passing through origin. But here acceleration is constantly increasing. So we will get a curve like this. Okay. This is a parabolic curve. And if we want to find acceleration at any instant, suppose at this instant we want to find instantaneous acceleration, we have to draw a tangent at this point. And slope of this tangent will give us instantaneous acceleration at this point. Okay. Now come to the last situation. A body is moving with decreasing acceleration. Just here acceleration is negative, so there will be a curve like this, VT curve like this. Okay. Here also, if we want to find out instantaneous acceleration, then slope of a tangent drawn at any point on this curve will give us instantaneous acceleration at that point. Okay.